Welcome to NCAST, the podcast from NOps. Each week, we'll explore the world of cloud cost management, the latest in AWS optimization, and getting practical about your FinOps journey. Join us as we dive deep into the latest trends, tools, and best practices while having conversations with leaders and luminaries who are innovating on the front lines. Our goal is to provide value to the community through insights and practical advice that will help you to achieve your FinOps goals. So whether you're in engineering, leadership, finance, or a cloud professional, this is the place for you. Sit back, relax, and get ready to join the conversation on NCAST.
All right, welcome to another episode of NCAST. We've got a familiar face here and a new face here. Conversation went so well last time. I've got a couple of team members from AWS's container services team. Andrew Park and Mike McDonald are partner solution architects or solutions architects. That's a mouthful for me apparently today. With the container services team. Guys, love it if you briefly introduce yourselves.
Sounds good. James, thank you again for having me. For the folks that didn't watch the first episode, well, first go watch that episode. But if you haven't, my name is Andrew Park. I'm a senior partner solutions architect here at AWS, focused on containers and application modernization. And so a lot of my focus is working with our partners, much like James, to kind of expand the container ecosystem through strategic partnerships. So thank you again for having me. Really appreciate it.
And hey, everyone, I'm Mike McDonald. I'm a partner solutions architect with AWS, also on Andrew's team, doing a lot of the same kind of working with partners to expand that ecosystem and really, help our partners grow as well.
All right, guys. Well, today we're going to kind of be all over the place, but one thing that we really wanted to dig into was the complexity of running AI and ML workloads in container orchestration frameworks. We talk a lot on this program around Kubernetes and optimizing for cost. And optimization is optimization. Andrew, you mentioned that really in order to understand the challenges that teams face moving forward, that you kind of have to understand where we were at before this massive migration to EKS. So maybe you'd like to paint the picture for us.
Oh, you mean before all the buzzwords like GenAI, machine learning, AI? You mean before all that? Yeah.
Was there a time before that?
I don't know. That's what I'm trying to figure out as we speak.
We're thinking of changing the company name to NOps.ai because, hey, you gotta.
But yeah, there apparently was a time before all the buzzwords. So I think to frame the conversation that we're gonna have today, I think it's important to understand kind of what machine learning and AI looked like before the cloud, before things like container orchestration and things like Kubernetes. And so what I'll do is I'll kind of talk about the challenges that, these types of teams face when trying to amplify those workloads traditionally, and then kind of what that looks like now with things like EKS, these different open source frameworks we have, like data on EKS, et cetera, et cetera. So some of the challenges that come to mind initially for me when I think about the challenges that these teams face prior to the cloud and things like Kubernetes is 5 different things. So the first thing I think of is scale. So the idea that you need to be able to reproduce and maintain model training environments is very expensive and can take a lot of effort. And so, you can't really have this expectation to have your data scientists manage that aspect of deploying and training their models, because they should be focused on training the models and deploying the models themselves. So if they have to also manage the infrastructure, they're not being as effective as they probably should be, right? So there's that, on top of the fact that they're probably doing this across different environments. That's the first thing I think of. The second thing I think of is the maintenance of tools. And so even today, when you think about all the different open source offerings and commercial offerings to help train, build, and deploy your models, there was still that problem before all the buzzwords, right? And so you have to think about all the different versions of Spark, all the different versions of Airflow, and all these different open source projects that were still, very popular before what ML and AI looks like today. So that in itself was pretty painful for, these teams that were deploying training models at quote unquote scale. And then on top of that, you also had the idea that it was really hard to augment and maintain different projects, and that in itself takes up a ton of engineering time and resources. And so, as teams grew bigger and as teams were adding more data scientists and things like that, this became very, very difficult to maintain all the different projects and being able to train all the different models and then also apply the different tooling that came into play. So overall, like maintenance of tooling was absolute nightmare. When we think about the third point, which is security, when we think about different industries like healthcare, financial services, there's a lot of compliance and regulations that these teams need to abide by. And so historically, before things like Kubernetes and these container orchestrators, this was also a pain point as well, because if you're working with highly sensitive data and you don't have the tools, the processes, and the governance in place within those environments, more often than not, you're going to run into a lot of trouble, right? Like if you go through an audit and there's even the smallest thing that's off, good luck. So that's the third thing. The fourth thing is more operations focused, and this is kind of where Kubernetes, these container orchestrators kind of help alleviate a lot of these concerns for the infrastructure operators. It's kind of like I mentioned with the first point. If you're a data scientist, like you don't want to have to manage the infrastructure itself. You should just be able to pick the specific GPU you want, the specific services that you need access to, and then just deploy those models into production, right? That is what a data scientist should be focused on. Obviously, depending on the organization where you're at, things might change, but generally speaking, as a data scientist, you should be able to offload the management of infrastructure to your platform teams. Like that, ideally, that's how it should be played out. But back then, that wasn't necessarily the case. And then finally, the most important thing is running these types of workloads at scale before the inception of container orchestrators was incredibly expensive. So before even the cloud, right? Like the idea that you had to build these massive data centers with these GPUs is incredibly expensive. And so those are really the 5 challenges that I think of before the inception of Kubernetes and all these orchestrators. And with the rise of these different frameworks like Data and EKS and all these open source frameworks to help manage your ML and AI workloads on things like Kubernetes, this whole process becomes a lot easier. So I know that's a lot of information, but I'll kind of stop there for any questions you guys might have or anything else I can elaborate on.
Well, there is a lot to unpack there. I would almost assert that you sort of open up a whole new world of complexity as you get into the cloud. Maybe we're going to really get into that. One thing that I heard you say is that all the data scientists should have to do is select the right GPU architecture and be off to the races. And of course, the cloud gives us the flexibility to experiment with those things. But in my experience, and by the way, I have another number of data scientists on my team who will admit to this fact. Oftentimes, data scientists are going to pick an instance size and type that just works, and that's going to be the last time that they ever think about it. And so, I would say that we're looking towards a future where we start to offload more of that responsibility on to DevOps and SRE teams, and the people that are managing infrastructure, and then looking at the overlap with FinOps teams who are looking how to actually play the markets and maybe even shape the workload patterns so that you're able to take advantage and scale with the admittedly very expensive compute that is required to build these models at scale. So it sounds like we've traded a lot of certainty and maybe expense for a lot of uncertainty that comes with flexibility. But how do you navigate that ecosystem?
Yeah, so I think to answer that, I think it might help to kind of like talk about at a high level what the AWS AI and ML stack looks like, starting from the compute layer and the different frameworks to things like SageMaker, And then at the top, you have like your AI services, right? So at the bottom of the stack, you have your infrastructure and then your ML frameworks, right? So the frameworks would be things like PyTorch, MXNet, TensorFlow, and some of the other popular frameworks that we see in the market today. And then you have the infrastructure, right? So you have your EC2 instances, which include your CPUs and GPUs. You have things like AWS Rencia, you have Trainium, and the list kind of goes on, right? So at a high level, that's kind of what the bottom layer of the stack looks like. So the next layer would be things like Amazon SageMaker. So this is actually where you're going to be doing, manipulating the data, training the data, creating different notebooks for your data scientists to actually leverage and use, and so on, right? And then on top of SageMaker, you can leverage things like EKS, right? So SageMaker on EKS or EMR on EKS, right? In order to kind of help alleviate some of the concerns I talked about earlier in this conversation. And then at the top of the stack, you have your AI services. So these are things like Forecast, Kendra, Lex, et cetera, right? And so those are kind of like the three layers of the AWS AI ML stack that I think about. And we actually just launched a pretty cool service that a lot of people are excited about, but I'll let Mike talk about that. Mike, you want to talk about that cool new service that we just launched?
Yeah, absolutely. So Bedrock is going to be kind of at the top of that stack that Andrew was talking about, where, at the bottom, we've got that infrastructure. If you're looking to try and build your own model, you've got a bunch of experts in-house, that works out perfect. You've got the tools to kind of do that. But part of that cost trade-off is going to be, if you don't have that technical expertise to build your own models and set up and run those foundation models, maybe having something more managed would be a good idea for your organization. So Bedrock, up at the very top of that, is going to provide customers, easy access to large foundation models for their AI applications, provided by both AWS. We've got a couple of models in there that we've created, and then also popular foundation models from other third-party kind of AI startups. And then in addition to that, on Bedrock, customers can kind of jump in and start tuning those models to their specific use case, providing way less data than it would take to actually build and generate their own foundation model. So as little as 100 different examples of their specific kind of use case, they can tune that model and then begin using generative AI in their application, that's specific to their application.
Right. Well, I can speak from experience and leading both traditional engineering and data science teams. One of the biggest decisions that I have had to make many times when investing in building out data and AI platforms in my career is whether it's worth the operational expense. Put any group of smart engineers together, and they will always come to the conclusion that they can build it and operate it themselves, which is great. But we don't have unlimited bodies to operate 24/7 maintenance. I cannot even tell you the hassles that I have put up with in my life running Spark in Kubernetes alone. It's a whole can of worms. So it sounds like there's a lot of tools out there, but what comes along with those tools is there's a cost, and so at the end of the day, we don't want the data scientists to have to think too much about operational efficiency. So how do we abstract that complexity so that the data scientists can focus on innovation, and then the people who are down closer to the infrastructure, or maybe even AWS, or pass it off to other frameworks, so that the efficiency of that system and the reliability and robustness and all the things that go along with that are inherent.
Yeah, so I think the reason why frameworks like Data and EKS is so crucial to kind of the conversation we're having today is because it allows the platform teams to choose the specific tooling and infrastructure specifically in order to enable the data scientists to innovate and kind of do what they're supposed to be doing as effectively as possible. And so a lot of what I've been seeing with some of the customers that I've been talking to that are using data on EKS today, some of the most common tools that you'll see is the open source project Ray. And if you're not familiar with Ray is basically built to train and serve ML models on top of things like Kubernetes or an EKS in this case. And on top of that, you'll have kind of supporting tasks or supporting tools that will enable Ray to do what it needs to do. So things like Karpenter, right? Because realistically speaking, the more workloads and the more folks that you onboard onto a platform like data and EKS, you have to expand and be versatile with respect to the number and types of GPUs that be using on said platform, right? So Karpenter is a huge part of it, right? If you want to create and spin up Jupyter notebooks so that your data scientists will have access to their own environments, you're going to have to use something like Cert Manager, right? Because the data scientists will have to access that particular notebook somehow, right? And then you have your supporting cast of AWS services, right? So things like S3, if you want to make an API call to Bedrock, your VPCs, the list goes on, right? But that's kind of the most common, a package of tooling that I'll see when customers use things like data and EKS, just because it really does make that process for data scientists much easier, a lot more effective when they're trying to train and deploy models. Mike, did you want to add anything to that?
I think you covered it pretty well there.
I mean, this is really a problem that we over at NOps. I mean, let's face it, we have evolved over time for being a traditional cloud management tool. It's what I would classify as a data and automation platform. And I mean, really, what isn't driven by data these days? And so what you lay out is really what I consider to be data as a service, right? And your data scientists are consumers of that, and you have to make it easy to work, or easy to use, and have the governance and compliance built in so that it's inherent to the system. Really glad that you brought up Karpenter. We talk a lot about GPU compute being very expensive, but then I think one step further is that there's so many different options for GPU compute, and so Karpenter really allows us to manage the GPU selection or the instance family selection, not only just to scale it when we need it, so that we don't have GPUs on when we're not using it, but also to pin it back to the deployment. That really seems like a huge advantage or advancement over the way that a lot of people are managing EKS with cluster autoscaler. Any other advantages or things that you think folks ought to look out for?
Yeah, so I kind of touched upon this point earlier in this conversation, but I think what I really like with respect to Karpenter in relation to making data scientists' lives and jobs a lot more effective, a lot easier, is that you can, as like a platform engineer or as a platform team, you can set a predefined Karpenter provisioner, right? And so when you do that, it makes spinning up resources super easy for data scientists, because they basically only need to focus on defining the desired instance type or GPU that they need to use for that particular model or that particular workload, right? Because traditionally, like, that was just a pain. Like, you could even argue that wasn't even possible, right? Like, you remember the days where you had to like submit a ticket to your SREs. The SREs had to look at the ticket, approve it, deploy it, and then that process in itself could take like weeks, right? But now with Karpenter and these different platforms that we're seeing today, it's so much more effective for our data scientists just pick the instance type that they need, spin up a notebook, and kind of just do their job, right? You also see this with things like EMR and EKS, because traditionally when you want to do those kinds of workloads, you'd have to manage your own Apache Hadoop clusters on EC2. And so the idea that you can just submit jobs when you run EMR and EKS, like, that makes a data scientist's job significantly easier, and it saves them so much time, right? And so the other thing I'll add with respect to Karpenter is that, let's say, you have a data scientist that doesn't necessarily need a GPU. For that particular workload, they only need CPUs, right? You can have different provisioners for GPUs and CPUs within Karpenter by defining those particular Karpenter provisioners, so that, as a platform team, you can just create all these separate provisioners within Karpenter. And so that if a data scientist comes in and says, hey, Maybe I don't actually need this massive GPU instance for my particular notebook or this workload. I just need a CPU. They just need to select it. They get access to it. They do what they need to do, shut down that instance or that workspace, and then they're done, right? So this whole process just becomes so much easier when you use things like Karpenter, EKS, and all these different frameworks that are available for training and deploying ML models on EKS. So that's kind of the benefits that I see from the customers at least I've talked to. And yeah,
I'm gonna flex a little bit here with things that we've released over here in NOps. So one further is that, and again, I just really proud of what the engineering team has done. But our NKS solution integrated with Karpenter allows you to manage multitudinous different provisioner and node template configurations, and then integrate them with our cost consideration engine to add yet another layer of automated optimization. I like to think of it as a set it and forget it. Most people configure a provisioner one time, and at best they come back and maybe evaluate quarterly, or when somebody yells that there's that the EC2 spend has gone way too high, and NOps is mutating Karpenter provisioners every 10 minutes, and the thing that we could bring into this conversation is just that the ease of being able to introduce spots into your ML workloads.
100%.
Right. And so, if you look around the ecosystem, a lot of times you can use these new inference instances, the G5s, the P5s. They're all going to be somewhat suitable, perhaps, to run the same type of ML workload, and as we know, diversification is really the best way to play the spot market. We do bring a stability factor in there too, where we will provision on an instance type or family that we think is at risk of termination, such that you can really look at running those mission critical workloads on spot and across a variety of suitable matches for instance families, so that you really never have to think about it again. Oh, by the way, it'll automatically manage all the commitments for your baseline workload too, and make sure that they're 100% utilized. So I guess where I'm going with that, aside from just saying that there is just so much flexibility, and now you can just automate it and put the optimization for your entire environment on somewhat of autopilot. It really has to do with just one team or one cluster, doesn't it? That's where things get really complex. Is now you're managing this across possibly 25 different EKS clusters with a bunch of data scientists that just want to cross their fingers and hope that their jobs get run on time with reliability, right?
100%. And I think, to your point, if you are running 25 different clusters that all need access to varieties of GPUs, like, that is going to get expensive so fast. And I think maybe one aspect of this picture that we're trying to paint for the folks listening is that we're not even talking about like the hybrid story, right? So if you're running these workloads in your own data center on your own GPUs, right? Like, that is in itself gets incredibly expensive too. So when you put all these things in perspective, like using a tool like NKS and even just understanding how Karpenter works under the hood, can literally save you so much money. So there's really no reason to not look into it if you're running these type of workloads, right?
Right. Well, we're big Karpenter stands around this place. But it's a case in point, right? We're talking about operating these ML workloads at scale, and it at a certain point it becomes a point of diminishing return to expect even any operational team to be making continuous change sets to to retune for markets and availability of resources that changes by the hour. Not, I would say, not sustainable, which is why automation is key, huh?
100%.
Absolutely.
Yeah, yeah. Well, and then one other piece of it is GPU efficiency, even within the cluster. One other plug for Karpenter is that it's got built-in support for time slicing, which allows your containers to share GPU in the most efficient way possible. In a traditional world, one container will have all the GPU or at least an entire core for the entire time that it's running its workloads. So native support for things like time slicing, where you can just turn it on, really say just again innovates the path to efficiency. So
no, I totally agree. I think an important point to note there is if you're running this at scale, right, and you have thousands of different Jupyter notebooks being spun up left and right, I think like that feature in Karpenter itself will save you so much time and so much money. Right. Because imagine if you had to spin up a GPU per Jupyter notebook, just like that's obviously not something you see today, but just imagine that thousands of GPUs just going up and down. Like the dynamic clusters would just be just insane. So yeah, I think that feature in Karpenter is definitely something that folks should go take a look at because it will save you money. Just period.
Right. I mean, the advances keep on coming. So we've talked a lot about sort of operating ML and AI at scale and in Kubernetes, but not to zag too much. There still seems to be a world out there where there's a place for ECS. We see it all the time. Well, and again, it's not derisive towards ECS, that you choose the right tool for the right job. And ECS is yet another layer of simplification and so elegant in the way that you can delegate capacity to an ECS cluster. Are we still seeing a huge amount of adoption in ECS, and how do those challenges differ for teams?
Yeah, so I'm gonna be honest here. I'm gonna go out and say it. More often than not, I'm actually more of a fan of ECS for a lot of like customer use cases and customers I've talked to.
That's a swing. That's a big swing.
And it goes back to this conversation of buzzwords, right? I feel like when a lot of folks like start their modernizations, they want to use the hot new tech. Like, what is everyone else using? Like, what is going to help me, just take my business to the next level? And you start kind of going down this rabbit hole where it's like, all right, it's great that you want to modernize. It's great that you want to take that first step in your modernization journey. But you start asking questions like, within your engineering teams or your IT teams, like, what percentage of these folks have expertise or even know what Kubernetes is? You start having this conversation, right? And you're just like, hey, if you just want to run containers, you don't care about all these open source tools, like, there might be some ISVs that you might consider. Maybe like running ECS might be the more effective option for you. Because if the answer to the question, I just want my containers to run in orchestrated fashion, then why not use ECS? Because with ECS, you still have access to all the AWS services that you would need, as you would with EKS, right? You still have access to the various GPUs and the GPUs and other ML and AI focused instances that you'd want to use with EKS as well. So if you think about it, the only thing that you're kind of taking away is that open source aspect. And depending on the industry that you work in, you might not even have access to the open source tools anyway, right? So in a lot of cases, sometimes ECS is the better option. That is my perspective. Mike, do you have anything to add to that?
Yeah, I mean, I'm kind of the same mindset. A lot of the, customers and partners that I've talked to that run on EKS or that, come in feeling very strongly about running on EKS a lot of times they've got like a multi-cloud kind of strategy in their head as far as like wanting to run different providers, which, is quite a bit more to manage, having your staff learn different platforms and kind of how to run it on different areas. For a lot of different applications, and most of the folks that I talk to, like Kubernetes isn't the requirement. They do just need to run their containers. And, the biggest complaint I get, or not complaint, but objection I get from them is a lot of the times like getting worried about kind of lock-in. But the point of containers is that you can take your container anywhere. Like you own that piece. The only thing, is that we're trying to make it more convenient by running it on AWS, where you don't need to mess around with Kubernetes itself. I love Kubernetes as a tool, but a lot of the different customers I've talked to, don't really need that complexity, and they don't already have the staff to be running it. So it's kind of more of a hurdle to get on board with that.
It's back to the, bedrock, or let the engineering team have a lot of fun and waste a lot of time building it themselves, right? And over at NOC, we have found that ECS capacity providers still maintain a huge portion of our own customers' compute spend, right? We know that they're out there using them. We've been pleasantly surprised in actually how the approach that we originally built for NKS, how well it applied to the auto scaling groups that underlie ECS. I think there's two things to keep in mind, because oftentimes you're going to end up with more ECS auto scaling groups than you even have with Kubernetes cluster. Lots and lots of auto scaling groups. But the two things that you really need to focus on are spot stability and organizational awareness of commitments. Once you put those two things together, you can very easily migrate a high percentage of your ECS usage to spot. And in fact, in most cases, in my experience, I'll just go out on a limb. Most of the workloads that I do see under ECS are actually very suitable for a much broader set of instance families, or much more suitable to be able to take advantage of those really, really steep discounts when they're available on the spot market. Is that kind of your experience too, or is there more of a spectrum of ECS workloads out there?
Yeah, I think the only thing I would add there is being able to run on Fargate. I think, a lot of the customers that I've been talking to as of lately, and really just of this year, really prefer to run their ECS workloads, particularly on Fargate, because it kind of helps to kind of flourish the picture of simplicity, right? Because when you use Fargate, you don't even have access to the underlying instance, right? So it's not something you have to think about. So I think that's the only thing I would add there. And it is a very popular trend that I've been seeing across our customers and our partners this year, for sure.
I guess warning to the wise, just make sure that your workloads are highly stateless. If you're on Fargate and you're on ECS, or if you're on ECS that runs on Fargate and you're trying to fiddle around with Spot, and it's very easy to enable, by the way. Spot and Fargate is like, I have customers come to me and ask me like, how do I optimize my Fargate workload? And I'm like, so just click that button, right? Just click that button, turn on the Spot, because it is mind-blowingly easy, but you have to make sure that your workload is suitable, because not much that we can do for helping a stateful workload that's going to take a big hit if you're trying to push real heavy into Spot with it, unless you can suffer the consequences, right?
Absolutely.
Yeah. Guys, you guys, I can't even believe time is flying away. I think we're like 40 minutes in. So let's start to circle the wagons and wrap it up a little bit. So final thoughts for customers out there. that are trying to I guess hit those two pillars, that they want a stable, easy to use platform that is also optimized for cost to run their ML workloads. Where do you get started?
Yeah, I'll let Mike take that one, and then I'll kind of add his thoughts.
Yeah, sure. I'd say, thinking about your workloads and thinking about what you want to build, and then really like trying to pick the right tool for the job, and thinking about, kind of what skills your staff have and what, you want them to learn, or if you want them to take the time learning, because, we've got all of these different tool sets that are fantastic to use, but really the first part in trying to make sure that your costs or your money's being well spent is kind of making sure that you're doing the thing that's going to be right for your application, with when it comes to spending time, tooling is definitely our friend. Tool sets, making sure that we're automating what we can, in the selection of those instances. Once we do decide if we want to manage our own compute, making sure we're bringing intelligence anywhere that we can into our applications is a big piece of it, because the time that your people are spending, is also part of the cost equation, and a big part of it that often gets overlooked by a lot of our customers and partners. So, yeah,
that's it. Teams, especially engineers, they want to drive a Ferrari, right? But a Toyota Corolla is a pretty dependable car. The maintenance is cheap. And so, but I think you nailed it on the head, Mike, right? Like, don't worry about what the latest buzzwords are, or the coolest sounding services. Pick the right tool for that does what you need at scale with the least amount of trouble, right? And the best cost. All right, what do you think?
So I think just based on the conversation we had today, if you are currently running ML AI workloads on EKS, or if you're thinking about starting that journey, the first place I would direct people towards is really the data on EKS framework, because we have a bunch of different reference architectures that you can deploy as just Terraform templates or even CDK templates to get started very quickly. And with that framework itself, we have support for things like open source project Ray. We have support for things like EMR and EKS. We have support for Kubeflow, SageMaker, and EKS. Literally any tool or open source product that you would want to use for those types of workloads in EKS, more often than not, we'll already have support for it on data on EKS. And that is really where a lot of our customers are heading towards, is really leveraging that framework to create the foundation to really help their data scientist teams and teams of that nature really flourish and really innovate at scale. So that's what I would say. And then, it's sure these are a bunch of buzzwords, but as funny as it sounds, like these are the buzzwords that are really transforming the way that we live our lives. And so I think it is something important that we should all start looking into, really try to figure out how we can integrate that into our daily lives. So that's what I would end with.
Cool. Yeah, and I'll just say that once you've selected that framework, head over to NOps and let us put it on autopilot, so you don't have to worry about pricing programs and RIs and spot market and and also that we can help you to allocate that shared infrastructure cost, which was something we wanted to talk about, but I feel like there's a whole other episode there, guys, because that one of the biggest challenges that we have. So I'd love to invite you guys back soon to chat about that whole side of the equation, which is, how do we bridge the gap with our finance teams to even figure out what our workloads actually cost. Okay, well, if you stuck with us this long, you're probably as big of a nerd as we are. So we take you for that. We find this stuff to be really cool. And if you have any questions, reach out to us over at NOps, www.nops.io, or send us a an email at incast@nops.io. We love to hear your questions. All right. Hope we can do this again soon, guys. Thank you so much.
Thanks so much. Appreciate you, James.
Thanks for tuning in to Ncast. We hope you enjoyed the episode. As you can tell, we love to geek out on all things cloud optimization. If you have any questions or feedback, we'd love to hear from you. You can find us on LinkedIn, Twitter, or Instagram, or just shoot us an email at ncast@nops.io. If you'd like to learn more about the continuing innovation over at NOps or about our free FinOps platform where you never pay anything unless you save money, check us out over at www.nops.io.